Assalamualaikum and hi, we are from group 2 and this is our video presentation.
So this is our team members, first AIYSHA, KHAIRIN, Balqis and AFRINA. In this video, we will conduct 3 tests focusing on understanding how pavement texture and drainage characteristics contribute to safe driving condition and road durability. There are 3 tests that will be conduct. First is skid resistance test, sand patch test and surface drainage test.
Safety precaution needed while conducting this laboratory activity is first, ensure all team members wear appropriate PPE such as high visibility jackets and non-slip shoes. Next is ensure all equipments are well maintained and avoid mishandling. And lastly, conduct the project in a safe area away from heavy traffic.
The first test that we will conduct is skid resistance test. The objective of this test is to evaluate the frictional properties of road surfaces under various conditions, and the second objective is to assess the ability of the pavement to prevent skidding, especially in wet or high-speed scenarios.
Before we conduct the experiment, we need to make sure that the skid resistance tester is calibrated so that the needle is set to 0 when the pendulum is weak. From you can see here, the needle has touched the 0, so we have successfully calibrated the skid resistance tester. To level the tester, we need to ensure that the bubble is inside the circle. Adjust the lever to ensure that the rubber of the skid tester touches these 3 points. Now we need to do 3 readings to get the average data. So now we will do the skid resistance test for wet surface. We will take again 3 readings for wet surface. Next, we will conduct the same experiment for the smooth surface.
Now for the skid resistance test, for the location we do for rough and smooth surface, but in different condition for each surface, which is dry and wet. For each surface with different condition, we take 3 reading and do the average to get average for British pendulum number. For the rough surface in dry condition, we get the skid number, which is 105.73, and in wet condition is 55.45. According to the Transport and Road Research Laboratory 1969 that used by the JKR, the minimum skid resistance is 45. Since the skid number is greater than 45, it successfully fulfills the standard. For the smooth surface in dry and wet condition, we get the skid number, which is negative 9.12 and negative 18.11 respectively. Since these 2 skid number didn't reach the minimum skid resistance according to the standard, so we conclude it failed.
As for the discussion for skid resistance, it is important for road safety as it affects how well vehicles can grip the road surface. So based on the skid resistance test, this resistance is by calculating the PPN, which indicates how much friction a surface provides. Rough surface generally offer better skid resistance due to their texture, while smooth surfaces tend to be slippery, especially when wet. Overall, maintaining good skid resistance through proper road surface design is essential for preventing accidents and ensuring safe driving conditions.
The second test that we will conduct is sand patch test. The objective of this test is to measure the macro texture depth on the pavement surface and to determine the uniformity of the surface texture and its impact on tire-pavement interaction.
Okay, for sand patch test, after we have preparing the apparatus, first we need to clean the surface of the road by using brush. Ensure the road have a range of 5.5 cm width and 5.5 cm length. And then pour 25 ml of sand inside the measuring cylinder. Pour the sand in the measuring cylinder by using funnel. the sand onto one point on a surface road and disperse it by using a flat tool. After the sand has been fully dispersed by using a circular motion, record the length, record the biggest length of the diameter of the sand. Repeat the same procedure but on a smooth surface.
This is the result data for sand patch test. For the location, we also do for rough and smooth surface. The volume of the sand we use is 25 cm3. We take 3 reading for each surface and do the average diameter, then we get 0.1677 meter. Then, we'll calculate the mean texture depth. So, the mean texture depth for the rough surface is 1.13 mm and the mean texture depth for smooth surface is 0.68 mm. According to the Transport and Road Research Laboratory 1969 that used by JKR, the average texture depth must more than 0.50 mm. Since these two surfaces are more than 0.50, we conclude it's okay.
Next is the discussion for sand patch test. For a surface, the mean texture depth is 1.13 mm, which exceeds minimum requirement of 0.5 mm. This high texture depth correlates with strong skid resistance. Meanwhile, for smooth surface, the MTD is 0.68 mm and it meets minimum standard but is lower than rough surface. The limited texture depth leads to poor skid resistance in dry and wet conditions. From these two tests, the rough surfaces provide better performance due to greater texture depth, and both surfaces meet basic texture requirement, but rough surfaces are superior for safety.
The last test that we will conduct is surface drainage test. The objective is to analyze the pavement efficiency in draining surface water and to identify area prone to water pooling which may lead to hydroplaning or pavement deterioration.
Today we need to do surface drainage test. So what we need is overflow meter. This overflow meter make sure the valve is closed. Then make sure the surface is clean. First we clean clean the surface first and then put the overflow meter. Then take water and we need stopwatch. Okay, so first step we need to pour that water into the overflow meter until reach 200 ml. After pour the water, we open the valve and record the timer using stopwatch. So we need 3 times 3 readings to get an average. So we repeat the same procedure on the smooth surface.
For the surface drainage test, we need to find the rate flow, which is the volume of the water divided with the average time taken since we take 3 readings for rough and smooth surface. The rate flow for rough surface is 36.10 ml per second, and for smooth surface, the rate flow we get 23.98 ml per second.
For discussion, the initial water volume for these two surfaces is 400 ml. So for the rough surfaces, the flow rate is 36.10 ml per second and the time taken is 11.08 seconds. Thus, rough surfaces efficiently removes water, which can reduce hydroplaning risk. For smooth surface, the flow rate is 33.98 ml per second and the time taken is 16.68 seconds. So for the conclusion, it has lower drainage capability and it retains more water, which increase hydroplaning risk.
Lastly, for the conclusion, this project will assess the pavement surface based on its skid resistance, macro texture depth and surface drainage efficiency complying with Malaysian road standard. So for pavement with higher skid resistance will show superior friction, providing safer driving condition especially under wet weather. Surface with greater texture were found to be more effective in enhancing tire grip and facilitating water drainage, and pavement with better water runoff significantly reduced water pooling and hydroplaning risk. Overall, the findings highlight that the pavement that complies with Malaysian road standard will perform better in safety and durability, emphasizing the importance of regular assessment and adherence to these guidelines to ensure high quality road infrastructure. That's all from us. Thank you.